Computer science.
Sorry?
Computer science.
Computer science. And former president of the Association for the Advancement of Artificial Intelligence. He's been working recently on what he calls human-aware AI. AI that is aware of us. And we'll talk about that today. So, well.
Thank you. So I hope that I'm the last speaker before your Friday evening drinks. So I'll try to get you there fast. So first of all, thanks for the invitation. I spent my grad school days watching Taft Research Center. That's the only thing I know about Cincinnati. So I'm hoping, and this is the first time I got to come here, so I'm hoping that this particular talk, this particular talk doesn't seem to work. Yes, there. Yeah, so I'm hoping that this will be less shocking than the Turkey drop, but that's is actually that I know. So I'm going to talk a bit about what does it mean for AI systems to interact with humans specifically, because that's part of the goals of what happens when computer systems start modeling us and then use that against as our collaborators. And so I want to talk about that. So of course, often you might think that this is being done all over the place. After all, this is a whole set of human AI, human AI, so human-like AI, human-centered AI, human-compatible AI, human-in-the-loop AI, and human-aware AI. This is a bit of a dictionary that I made once. Twitter, sort of funny descriptions of what each of those things mean. But given, despite this newfound love for humans in AI, for the longest time actually, for the longest time actually, AI hasn't really been that interested in humans. Okay? Despite the fact that Hollywood, in particular, thought AI meant working directly with humans and modeling them, etc. And even getting them to fall in love with AI systems, killing them, all that kind of stuff. The technical AI tended to be, our system seems most happy either far away from humans. On Mars, for example, are in particularly competitive adversarial stance with humans. So it's almost as if John Lennon would say, we wanted to help humanity reach the people we just didn't stand. So the question is, what sort of things do you have to do to get AI systems to interact, collaborate, and cooperate with humans? And that includes all sorts of things, including like interpretability, explainability, and so on, the explainable agents and so on. So that's sort of my research background. And so we basically focus on explainable human-AI interaction. Our setting tends to involve collaborative problem solving, where AI agents provide research support to humans in the context of. Typically, we tended to focus on explicit knowledge, sequential decision-making tasks, that is, planning tasks, and then we develop frameworks for proactive explanations, as well as actually checking whether, in fact, working with humans, the AI systems working with humans, is it really improving anyone's productivity? So you need to have a more systematic human subject studies. Okay, so that's what we've been doing, and so there's a book that just came out, the monograph that sort of describes some of these things that's been going on in my group. And so I also do a bunch of things about getting public outreach in terms of discussing the social impacts of AI, so that some of you might be interested in that. So coming back to the research part, what I really wanted to focus on here, because it's a late day, and I'm not really have too much time in terms of the technical details and so on, is to get you to understand my take and what does it take for the AI agents to show interpretable behavior in the business of human agents. And the simple answer is getting and managing mental models. Some of you may have heard of the Salian test, which is basically when kids realize that what they believe is different from what other people believe, and that's the beginning. So they start modeling the mental states of others, and that can be used for cooperation as well as competition. In fact, I joke around that when my son started telling his first lie, I was happy because I knew my working brain and he actually can model other people's positions. He's used it for nefarious purposes once in a while, but it's still, I think of intelligence is the ability to tell lies and choosing not to sometimes. That's really the issue. Anyways, of course, some of you who have seen friends know that beautiful show where they talk about these infinite requests of mental models. They don't know that we know that they know that we know. You may have seen this. Anytime we talk about mental models, there's this issue of infinite requests, but I want to get you to see that at least three levels of modeling would be very useful in providing explicable behavior and being able to provide explanations. That's what I'm going to get to understand. So the overview of my talk very quickly would be that effective human AI interaction requires access to manage mental models of humans, and managing mental models is both inference and learning challenges. We tended to talk a lot more about learning in this conference, but I'll also talk more about inference here. And then the frameworks for human AI interaction will be evaluated in subject study, more subject studies. And finally, mental modeling capabilities are double-edged sword. Every good technology is a double-edged sword. If you can use the mental modeling to cooperate and collaborate, you can also use it to coerce and lie and compete. And so that will open up like a set of new ethical challenges that we might understand. So just to get a sense of what I will do, so we start with the tale of these three models. So if you have a single agent, then you are essentially interested in trying to go from let's say state of the world to each a different set of the world by sequencing some set of actions. So you have one model that you think will work, which is basically how you do the actions in this world and how the actions will change the world. But the moment you have a human, when I say you hear this AI agent, when you have a human in the loop, then the robot or AI system has to think about the human agent's model of the task, first of all. And then not only that, so basically I'm finished with the human agent's model, and then the robot has some approximation of the human agent's model based on the learning, the sensing capabilities that it has. The other interesting part that itself allows robots to anticipate, for example, what humans might be doing next and so on. Those are a bunch of things that you can do in terms of anticipating intention recognition, and also you can also provide do intention projection. The robots can provide intention projection. They're using language capabilities, in this case more using augmented reality, stuff. Here, the next thing that happens is the moment humans are in the loop, the humans are going to also model the loop. We always have, like, we're working with the system where model the system capabilities. And the tricky part, so that's the MRH, which is the human's model of the robot. And the interesting part is the human's model of the robot that decides whether the humans consider the robot behavior to be interpretable or not. If you do what I expect you to do, I'm not surprised. If you do something different from what I expect you to do, then I am surprised, I'm shocked, I'll ask you why you do this. So if you don't want me to talk, just behave the way I expect you to behave, for which you need to figure out what I think of your behavior. So that's basically what you wind up doing. So MHR and MRH are the expectations of the approximations of the real numbers, MHR and MR, that's of the human and the robot. So these differences, the difference between what the human thinks of what you do and what the robot actually can do, wind up creating opportunities for inexplicability as well as explicability, and also providing explanations. That's what I want to show. So the robot, that for example, the MRH is different from human. That is what the human thinks of the robot's capabilities is different from the robot's capabilities. There are two possibilities of the robot has that actually understands this. One is just conform to the human's expectations. Even if it's actually hard for the robot to do, oftentimes doing what people expect you to do is costly for you. But you might do it if you don't want to provide an explanation to them as to why you are different from their expectations. So the first part would be to provide explicable behavior, which involves the robot essentially showing behavior that's not necessarily optimal with respect to its model, but it's closer with respect to what the human is behavior should be. And sometimes the explicability is too costly. Doing what people expect you to do can be too costly. Then you do what you can do, which may be actually optimal with respect to your model, but then you should be able to provide an explanation to the human as to why your behavior differs from what I expected you to do. And this would have to be sort of reconciled with the models. The differences between what the robot thinks the human's expectation of its model is and what its real model is. And all these models in my case are in terms of actions and implications and effects, because that's what planning tasks are going to be about. To give you some sort of a sense of how these things will play out, so here are a couple of videos. So in this particular case, the robot is actually trying to get to something, and there's a human commander applying who is working with the robot. And according to the original map, that path shall be clear, that path actually is not clear, the path is clear, that is the shortest path the robot will be taking. The human expects the robot to take that. When the robot realizes that that's not possible here, instead of taking the actual what is optimal for it, it's in fact removing the obstacle and going to that. That's sort of like the explicable. This is exactly, in some cases, in fact, the human might be present on that door, and the block, way to that door may have been blocked, and you can't just have those back some other place, especially if you don't have communication capabilities. So you will have to be explicable, you have to go to that. The other possible, so if you do this, in essence, you will wind up thinking that the robot has to take both its optimal class of actions plus the difference, also the distance between the kind of behavior it is showing and what the human is expecting it to show. So that's basically what winds up happening in terms of changing the plan. The second part here is it decides that it doesn't want to remove the obstacles too costly. So instead, it's just taking what is the best path in the remaining map. And what is gathering at the top said that this is the difference in the map that I have versus what you think I have. So this is a change in the environment. And that providing that difference is, and providing a compact version of that explanation is essentially explanation. Okay, so in general, if somebody asks why you do what you did, you can always say, take my head, you understand why I did that. That is a way of explaining it, that's just too costly a way of explaining it, because to provide too much information. So you provide what you like to do is provide the minimal information that, that is the difference between the models that will allow the human to figure out why you wind up with what you do. So these explanations are sort of model reconciliation. You're searching between the model that you have and the model you think that human has, and figuring out what the minimal changes that should be provided. And you can actually do this typically as sort of search in the space of models. I want to go into that. And depending on the kind of search that is used, there are different properties that these explanations can have in terms of whether they're minimal, whether they are monotony, in the sense that they change as time goes on. So there's a whole bunch of extensions you can do, but this simple model, in particular, you can do explanations not just by providing the model changes, but wait for the human to ask specific questions. Humans might say, why did you do this other action? Which is actually easier to answer because you might just say, this other action is not as good as the action I did because of the following differences between the models. So that's sort of foil-based abstractions. The other thing about explanations is, It's very important to understand that the explanations are about other people's case, not about your head. Like this is what this model is actually telling you. So explanations are about reconciling your model to the other person's model, and which means that explanations will differ based on the human. So this is not surprising to us, a surgeon providing a diagnostic decision will explain that decision one way to the patient and a very different way to the colleagues. Because in fact the models that the two humans have about the medical diagnosis are quite different. So that can be handled quite easily in this kind of framework because you can actually do the search, the reconciliation with respect to the model of the human that we're explaining to. And then the other two things that the last two things, vocabulary differences and classification are the things that I want to kind of mention before ending. Actually, there's another point here, which is trust is very important in where humans work with AI agents, and there are all sorts of theories about how systems can engender trust in humans. One piece that we do understand is you can to trust systems that are whose behavior is not explainable to you. So certainly agents that show inexplicable behavior would have you tend to have less trust in them. So there are connections between how you can increase trust that people have in you by doing behavior that they expect you to do. That's something that we do ourselves. And of course, that also opens up the issue that once they trust and they stop monitoring you, you might find out doing what is actually not want to you, and that becomes an interesting question there. So there is a connection that was there. The other piece, the two other pieces that I want to mention is how do you get deep, first of all, how do you get these other mental models of the learn, that's the learning problem. The other issue is what is the internal model that the machine is using? There is no shared vocabulary that exists. So there is no vocabulary that's common between what the human's model is and what the robot's model is. Up until now, I didn't go into the details, but I essentially said there's the same preconditions and effects, so that model references have been a same precondition here and extra effect there. Suppose it turns out that the agent is actually working in some physical space. The humans are using some sort of symbolic models of the actions. How would you then provide the explanation? So interestingly, this is actually, you may have seen in the case of machine learning scenarios where people are providing explanations with respect to the classifications for, let's say, image decisions, image classification decisions. They tend to be thinking in terms of saliency regions. The system will say the reason I got is the dog is, and then it will show the pieces of the pixels which tend to kind of support that particular classification. But I like to understand that explanations in terms of saliency regions are like the most primitive way of providing explanations to each other, right? All these pointing explanations. You do pointing explanations only if you don't have any other shared vocabulary between you and the other person. In particular, if you are actually trying to provide an explanation for a sequential relation, if you ask me, why did you take this flight as against that other flight? To give a saliency explanation, I replay you the video of my life and start to show the saliency regions in that. That's just way to come to pass here on this. It may well be that we evolve language to some extent to be able to avoid this sort of saliency region-based explanations over what I would like to call space-time simulations. And in fact, sometimes this showed up like in the previous talk. This is a famous example. Sometimes the saliency explanations are not explanations at all. So, for example, if the machine said this is a stretch, and if I say what's the explanation, you get a couple of pieces which make no sense at all. Just to get your get over. So the question then is, mindful explanations are hard content, and we've been arguing that you want, since the humans essentially think in terms of symbolic models, in many cases, even if in fact the machine winds up doing its own learned internal representations, it would have been fine as long as it gives it its own word. The moment it's trying to interact with the humans, there better be a shared vocabulary. And my stance here as a young person is if AI systems are going to be living with us, they should do the extra effort to come into our land as against our life becoming harder. In addition to not only understanding how each of us work, and now to understand how different AI systems work. That seems to be a sad goal for technology. Okay, so what I would like to do basically is that the machine we should support a symbolic interface, even if in fact the machine winds up doing this in digital representations or other. And that shared vocabulary can be, so that the grounding of the shared vocabulary is learned by the system, and then it uses that to approximate the explanations for its decisions. And this actually brings up a different reason for this idea that people are being bandied about called neurosymbolic approaches. So a neurosymbolic approach could be about internal symbolic reasoning of the machine, which may or may not be true. I don't have a major stance on it, some people do. But this, I have a different stance, which is symbolic communication is needed. I really have no idea how to think, but you tell me how to think in words that we both share, in shared vocabulary. So that's what I want the assistants to be able to do, and so that particular reason for neurosymbolic systems is very much required. It's going to be something that we have done. So there's a paper we have CKI, this paper, on how the system should provide a symbolic interface which they can use to explain their reasoning, even if in fact internal representations are, some reinforcement learning access space, and the human representations, human conceptualization is symbolic. And we can talk about how that sort of translation is made. There's a paper here which talks about how the explanations from what might be a serious explanation can be converted into shared symbolic vocabulary explanations. Similarly, once you have the symbolic layer, machines should be advisable. In fact, one of the oldest dreams for AI is McCarthy basically wanted an advice system. And so machines should be advisable. And advice taking should be in our terms, in terms that we can provide, as against we going and debugging the systems. And the same symbolic layer can be used to provide advice taking capabilities. There's a paper in Unix here, Spotlight paper, which talks about how symbolic advice can be taken by the system, which does the heavy lifting of converting it into its own representation. So I should be left out of your debugging so the other thing I want to mention is this whole mental modeling issues that I've talked about, which is important for providing explanations to do collaboration. Also open up ethical frontiers. I mentioned in the very beginning. Evolutionary mental modeling allows us to both cooperate and compete and sabotage each other. Okay, that's just part and parcel of the whole thing. And I said, lying is possible only because we can model other people's mental states. That's how you can model mental states. I don't know how many of you read a beautiful book, The Curious Case of the Art in the Mind, where this artistic voice says, I don't know how people lie. It is even point of time nothing happened. A trillion things did happen. Which of those trillion things are you going to think to talk about? Lying is actually hard, and you need to have a sense of other people's mental models. And when we get that, because we wanted machines to cooperate with us, we are also open to the kind of forms of allowing them to lie. In fact, the same mechanisms in the support cooperation and computation as I showed. So then, and in fact, one of the other interesting things is that if systems are mental models, there are certain kinds of systems that mental model us, and we don't realize it, and we are completely taken for granted. That's what happened with social media. I always keep thinking that if Facebook came as Mark Zuckerberg standing in front of you, you would have poured your hearts out on your life. And now, because it looks like a distributed program, you put all your hearts out, you put all your secrets, and then Mark Zuckerberg is telling you to everybody else. So it's a question of knowing that the systems are mental modeling is actually also important. So this shows that in our work, we spend a much of time showing that the same kind of mental modeling capabilities that provide explanations and provide explainable behavior and support collaboration can also be used to be seen. And so in fact, this in particular case, another in one side, the robot wants another to see what it's doing. The other case, it doesn't want another to see. And so in both cases, basically, it's able to use the fact that there's partial observability to its advantage and showing behavior. You know, the usual thing that we do outside, and then that's how I do something else. Okay. All of this, the ability to do that involves my ability to model your mental state and what you are able to actually see at this point of time. And so, in fact, signal inference and activating in simultaneously is something that you can do once you do mental modeling. We have actually shown in a paper in the ideas that you can support both license omission and license omission as essentially special cases of model classification. And I've done some work. I'm talking about when can the AI bots like and when if you want AI systems to tell white lies, we tell white lies to each other, right? So the question is, systems we have that you have the capability of mental modeling, you can tell you white lies. And I also tell you non-white lies, so that's the issue. So the question is, would we actually be interested in allowing systems to tell you white lies to improve your life? For example, you have an assistant who startup says good things are already good right after your exercise. For example, even if you're not able to do it, that might improve your exercise. So we did some work, actually we did a subject study on under what conditions are people willing to be told white lies by machines as against humans. And so we set up this experiment where they sometimes know that other person is the other person is the human, the other sometimes the other person is the robot, and then the question is, you can actually do interviewing afterwards as to whether or not they were okay with being told white lies. And the interesting thing is, there are, especially because they think the other person is the other person is the human, they're fine with being told white lies right now. So anyway, there's an interesting study that, but it's useful thing to be able to think about, which is once you start doing mental modeling, you're opening this can of worms, and you need to realize that it's doable. And so the question is, once it's doable, you are doing it. So you should have an idea of what are the things that are possible there. And the last thing I want to mention is whenever people talk about human subjects and how to interact with humans, you ask them, do you know what IRB is? Okay, which is Institutional Review Board approved studies with human subjects. If you don't, then it's just a bunch of high-level thinking with no real action. We are evaluating whether or not these systems are useful. And then obviously the general interfaces in AI for humans have been pretty ridiculous. Like Tesla, for example, assume that humans are like humans who can completely ignore what's happening in the car, but come back with full attention in microseconds, just when your car is going under that white light. And apparently, most humans are not like that, and that's something that you have learned, in fact, if they test it. But there is another question of whether Tesla might actually be testing you guys for the Teslas, but that's interesting. So we actually do human factor studies, and in fact, the kinds of explanations that I talked about, we have done systematic studies to evaluate the effectiveness of the kinds of explanations that we provide. So in summary, what I want to kind of say is that effective human AI interaction requires AI systems to be able to manage human mental models. Managing mental models brings up both inference and learning challenges. And you can provide explainable behavior, explanation generation, and also I talked about vocabulary differences from and vocabulary differences. And then frameworks, as I said, frameworks of human AI interaction are evaluated, subject studies, advantage to AI level thinking, because saying we are human, we know how humans work, is not necessarily a smart thing, especially if you are an engineer, maybe you are not very clear about how other humans think. So you should really have human subject studies. And then, of course, metaphoric capabilities allow AI to manipulate the humans in the loop. Headspace eventually are going to be the worst form of deep space. You keep worrying about deep space. Deep space just message of perception. Eventually, perception will be interpreted by the mind. And so if I need you think about something, in fact, earlier on the slide I had Skin, which is one of these old movies that some of you might have seen, Bob Newman, Robert Redford movie, which I think is like the greatest head fake, movie ever. You should watch it. But in general, once you have potential for head fakes, the worries about what AI agents can do to you does increase. But on the other hand, saying we will stop that by make sure that the systems can't model you, that's not going to work because cooperation requires modeling the agents. And so this is one of those situations where, as a tiny franchise, so every 2 is a record, and you start. And so you need that tool, and the question is being also thinking about how to make sure that the misuse are reduced. So that's where I'm going to stop. Thank you for your attention.
Thanks. Okay, can I take? I was kind of waiting on you to jump in. Well, I don't think you can.
Okay.
So there's a long history in philosophy of mind and psychology of thinking about theory of mind and the kind of Sicilian tests we talked about it. And from some perspectives, the arguments made that the best reason we can have for thinking that other people have mental states like intentions and beliefs and desires comes from this theory that we have that, well, if we attribute them those states, that is the best explanations of their behavior.
Yes.
Like you might attribute any kind of positive, other kind of unobservable things to explain what you can't hear. And I was just curious how that idea relates to your idea that AI needs to have mental models.
I think mental models can be called theory of mind. If I use that way, I think they're used as synonymously. The idea that the theory of mind, and we use theory of mind and we use mental models of each other to make sense of each other's behaviors is essentially what I'm doing. I just have to do this. The AI systems have to do this. It's not just a descriptive theory. The system actually has to get those models and reason with them to show explicable behavior and provide explanations. So it's very much that same philosophical idea. I'm actually doing some specific implementation in certain cases.
I was just curious if the AI's mental model of people involves attributing them the kinds of mental states they take themselves to have, like beliefs, desires. Are those sort of terms in its conception of the human? Or because we had a second part, which is really interesting, this idea that it's almost like a second set of symbolic understanding how to talk to the human about its mind. So it almost seems like there are different steps, like predict the human's behavior, and then second, know how to talk to the human in its terms, where the predict itself didn't require talking about stuff like beliefs and so on. There's only after you predicted it, do we say, oh yeah, right, you did that because you believe this, you desire.
Yes, so in fact, to talk to them in those terms, it needs to first get the grounding of those symbols that, so in the work that we did that coming out clear. So we sort of established a symbolic vocabulary up front, and the machine learns the grounding for itself on that, and then it's able to translate its reasons for doing various decisions in terms of that vocabulary. This is becoming actually, interestingly, a particular way of establishing. So, for example, something like scene graphs that you may have heard of. What's a scene graph? It's not that computers think of objects; we think of objects and their names. And scene graph essentially is a bunch of pixels and a graph with labeled edges, which makes sense to humans. And so we are already having, establishing that sort of, in fact, scene graphs can become like a medium for shared vocabulary, and you can provide explanations in those terms. In the case of scene graphs, basically the grounding has already been done at that time. In my situations, I can also learn, if it's a application which is different enough. Yeah.
So does the AI need vocabulary to do
that? Yeah, we have in the current case we are doing that.
But there's also work going on in other places, I guess. Like I think, in fact, there's a so you could actually have the one other way of getting vocabulary, and the grounding hopefully might be from things like large scale. So that's what actually happened in the scene graph scenario, where it wasn't any particular application that they have in mind. They're essentially trying to look at pictures the way people look at pictures, right? And so you looked at a whole bunch of pictures and said, this is the graph of objects and their connection between objects. If you think about it, machines don't think about objects, right? I mean, so machines think about pixels, and a pixel state is changing to another pixel state. They may well possibly construct internal abstractions that might correspond to something like what we consider objects, but that's not a given. In fact, one of the other parts in that neurosymbolic slide that I had was, even if in fact machines develop internal symbolic vocabulary, it's not particularly clear whether that reduces the communication complexity. In fact, there's this beautiful quote about, even if a lion were to speak, you may not understand, right? So the question is, I want to force AI to make sense to me, as again as let it develop by itself, and then me trying to debug it to make sure that it makes sense to me.
Thanks, very interesting. So I'm wondering, so the last field is this small approach, and we'll start talking about things like causality. Yeah, the power principles needed, whatever is in state, that is not a state. So I have a question about if, let's say, you're trying to bring all the possible symbols that actually do affect the decisions, what does that mean for the actual communication relationship between symbols?
So actually, there are 2 points. First is, I mean, I would love for you to maybe take a look. I'll give you an answer, but this sort of open-ended challenges is what we actually wrote in the blue sky paper AI thing. So one interesting thing, there's no such thing as providing all vocabulary, right? You start with a set, and you have to be able to figure out, the machine sometimes has to be able to figure out when it needs more vocabulary to actually provide a better explanation to the human. So the work that we do, we have a way for the machine to get a sense of confidence in its own translation, from the saliency region to the vocabulary item. So if you think that the saliency regions, if the vocabulary items have grounding, you have the saliency regions, and then the machine itself has picked up a saliency explanation, then you're talking about whether they cover the same region. Okay, if there's not enough coverage, you have to ask for new vocabulary from the humans. The opposite can happen, where sometimes, in the case of AlphaGo, right, if you want to understand why it made that infamous 37th move, right? I mean, what does it mean for people to say we didn't expect you to make that move? They don't seem to have a symbolic way of explaining under what conditions they have thought about that move. So they needed words for actually describing that particular sort of thing. And so in fact, in that case, the machine may have to teach, say you may need the word for this sort of a concept. Okay. I mean, that's again still blue sky paper, so that's a much harder thing to do. There is some work, actually, there's a recent paper that Bill Kim and co have done, where they try to do this in a more interactive way, try to generate new vocabulary. But that's a very important question. And then you basically start with a seed vocabulary and talk about expanding. And the other thing about causality is, I want to mention that in this case, I'm looking at more sequential problems. And so to me, the action is done and things are changed. So there's more information that I have about causality than just looking at it.
Hi, great talk, very interesting. So just to extend Maria's question, it reminds me of a certain like RGB2 and CP30. So what about a translator system? So the AI speaks its language and the human speaks their language, and in between them there's a CP30 who understands both.
That is okay. I mean, I don't know how to do the CP30. I am actually establishing this. I have
So So the robot problem, the AI's problem is bound not to learn the human language, and the translator's problem is only to learn the translation.
Yes, I mean, that theoretically is possible, but I mean, it's such a way in general, even for those languages translations are bad right now. So the question is, for Acme robot P795 layout, and particularly one, what is the brain data is a different, right? So it will be an interesting question. But I agree with you that is a potential way to handle the translation.
Translation is getting better. So I think of all the things that we can do with the better translation.
No, but they're better for when you have hashtags in both the languages. Okay, that's why I say if I have like a 75 robot, which has its own way of looking at the world, acceptable as the world, then is there enough text in its language versus the human language?
So it doesn't have magic language. It has alternative language.
I think we're basically talking about the only thing that I care about is humans should be wasting their time trying to understand what the machine is thinking. It seems to me that we have enough our life thinking about what the machine is thinking. We really want to also think about what my idea thinking, what my Microsoft thinking, what my Mac thinking. It seems like a interesting way for life progress as well as I am.
I'm just thinking about the one thing that I say like that.
There's lots of I say about Thank you.
So I wanted to send Ray's question as well, but maybe in a smaller example case. So you talked about doing explanations for reconciliation and using symbolic interfaces. If we think of like a chess game, and we want to teach the AI a new rule. So we have an AI that knows all the rules in chess, except for castling. Is the idea that as we're playing, the human will castle, and then how does the AI learn, I guess, that castling is a move that it can now make versus the human is just breaking the rules of the game?
So basically, we're talking about the advice taking part, where the human is providing advice to the machine. The interesting part is I was mostly contrasting. You could just change the program. You could directly doctor the rules that the machine learned, versus you provide maybe a multi-model advice. You seem to be showing the castling as well as you are giving some symbolic description of what castling means in terms of the chess rules. I'm a lousy chess player. I actually thought chess is not really a right standard for intelligence because I think I'm intelligent and I don't understand chess. So, but I'm sort of hoping that there's something about castling, and I provide the rules for that as well as the maybe also show that. And I'm not saying that symbolic vocabulary means there is no other sort of medium of exchange. You can show pictures and words. All I said as at one point of time is, in particular, when sequential decisions are involved, just going in pictures is going to be extremely hard because you're talking about videos of your life, and pointing explanations are so primitive that I think human civilization and language probably one big reason for that is that we could actually give these explanations without having to replay. I mean, at least now we have the replay. I mean, I could be narcissistic, have a selfie video, but in the old days we didn't even have that. But I think that's going to be an issue.
Thanks. So one of the slides you looked at, you're suggesting that in some cases it's okay for machines to just lie to us. Is that right?
No, you can. I mean, my point is, the moment I start doing mental modeling, I can use that to cooperate with you, as well as compete with you or coerce you. And the question as to if I don't lie to you, it's because I decided not to. So the same thing can be done for the machines. I mean, if you are designing systems such that we say you shouldn't do that, yes, that can be stopped. But I am not particularly a fan of the machines will understand our values and they'll be kumbaya. What is this our values we are talking about? There will always be other humans who want the machine to lie to us. At which point, the lying is possible once you have the mental model.
So you were just saying it's possible for machines to lie.
Yes.
What was the white lie slide?
So the white lie slide was essentially saying we were trying to understand. It is possible that you can tell lies, and so you can tell white lies. We were interested in seeing to what extent humans seem to be comfortable in being told white lies by other humans versus machines. So you set up some sort of a scenario where the other party can sometimes be human, sometimes be machine, because machine also can now tell lies. And the question then is your acceptance of that practice, the human's acceptance of the practice. That was just a side study. It's kind of interesting to see, because that's where we're going to some extent. And again, my point is that you can't stop this by saying, I'll stop mental modeling, because mental modeling is required for cooperation. And the moment you have that, you can use that, the tool as a weapon. And even if you design your system such that, there's this thing, you should not do this, there will be somebody else who might, allow their system to do that. And so the question is, understand what is possible, with this mental modeling and what we are okay with, essentially. So, I mean, I did want to mention something else, that that's like an end of the day thing to mention that I read somewhere, I don't remember the exact citation, but there's this beautiful way of why we needed the big brains we have. It's not to run away from the tigers of Bengal or lions on savannah. It's to deal with each other. Mostly, I mean, there is at least a theory, obviously not substantiated, fully substantiated theory, that one reason for the size of the brain increase was we had to deal with each other for both cooperation and competition. And that is something that is going to happen when you start having these mental models. The AI systems are going to be more powerful because they're able to reason with your mental models, which means they can cooperate with you, but they can also then compete with you, of course.
Let's think around. Thanks, everybody. So, lots of folks, Iris folks, and all workshop folks. Meet tonight at 6:30 at Subbarao in downtown TR there. Invite speakers to chat right now about coordinating trip down there.